Hey everyone, it's Dr. Leith. Today I'm going to go over distribution and scales. Boy, just what a great semester we're all having, huh? I hope the online courses are going well. If there's anything I can do to help or improve, please let me know. That's how I can do best, by getting your feedback, and later on I'll have a formal survey out for you guys to give me that feedback. But let me know what I can do to improve the course for you. I want to make sure that you're leaving the semester and leaving the course with what you want to know. So let's get into distribution and scales. This is going to be the first in about 3 to 4 weeks that we cover psychometrics. So this is on the PowerPoint or on the learning module for all of you. Oops. Why is my computer? There it goes. So let's begin with a hypothetical. Let's really set the stage for why all this is important. Say you have a friend. He comes to you. He's having a really hard time. And you say, "Hey friend, what's going on?" He tells you, "Breakup. I'm having a hard time. Lost the love of my life. This is hard." And you ask questions like, "Well, how long did you date? How long was this going on for? I didn't even know you were in a relationship." He goes, "Well, we just went on like 1 or 2 dates." And she said she's not interested. Something about she's moving away. He's really upset, like uncomfortably upset. And you say, "Wow, geez, this guy, he's hurting. He's clingy." But how clingy is he? It's an important question. To answer this question, we have to look at norms. We have to look at, is this guy as clingy as anybody else, right? So what is the average level of clinginess for a person? To put it in perspective, I had an intern once who wanted to do an attachment scale on a client who had some dependency problems, right? Couldn't really make decisions on her own. And so to figure out how dependent or how clingy, or whatever you're trying to measure, how independent, how confident, anything like that, we have to compare it to a group. So is this the normal reaction? We don't know. Let's find out. We collect data, right, and we make what's called a distribution. And we look at a group of scores. We give a survey to many, many people, and this is how they make assessments, how they make tests. The NCE, for example, or school counselors, when you do or prepare students for, I used to call it the TOS test. I think it's called STARS now, or STAR. Those tests are given to many, many people to see what's the high score, what's the low score, and what's the average score, and things like that. And we call this spread, this range of scores, right? If I were to line up all the graduates who took the NCE and lay out all of their scores, how many people got 90%, how many people got 80%. If I took all the students in my classes and said how many people got A's, B's, C's, D's, and F's, that's a distribution. And this is familiar to all of you, right? A histogram, right? Y'all have seen this, right? So along the bottom, let's get my pen here. We would say, I think in academics, this is, we'll say it's B, B plus, A plus. There we go. And then, just this, for the sake of not making you guys cringe at this anymore, then we'd have C, C plus, C, and so on, right? And going up this way is how many people did we have, right? How many people got B's? 20, right? Then maybe 15 got a B plus. Maybe only 10 got an A. 5 got an A plus, right? So this is a histogram. And we put this curve, right? That's our distribution. So when you guys hear things like a curve or a bell curve, that's what this is, right? We're just making a bar chart and then drawing a line over it. And that's our distribution. And so we have these curves, and there's different types, right? There's skew, there's kurtosis, there's bimodal, there's all these different curves, right? Right now, what we're interested in is a normal curve. And that's the thing that all these assessments are built around. In fact, most of statistics is built around the assumption of having a normal curve. And so the more people I collect, right? So let's say I make this clinginess scale. I want to see what are the different scores, right? So I give it to, let's say, 100 people, and I see very few people score over here at the extremely clingy end. Very few people score very, very low at perhaps the insensitively independent end. And most people are kind of somewhere in between, right? So this is how a normal curve looks. And that's what it's called, a normal curve, right? I use that term normal because that's what it's called. And when you hear that term normal curve, you will associate it with a couple different assumptions. Here's one of them, that it is symmetrical, right? You can fold it in half. And that's important because what it tells us is that, let's say for the 100 people that I gave my cleanliness scale to, half of them will score over here and half will score over here, right? So I was going to try and make 0.5 and then messed up half. And right here at the center line is our mean, right? The average score. So if you ask the question, well, what's the average level of clinginess? Whatever number is here, that's it. The average will be here. It's also the mean, median, and mode, right? Remember, the median is we line up all the numbers and it's the one that's in the middle, and the mode is the one that is most often reported. But that's it. What you need to take away from here is that a normal curve is symmetrical with half of the scores falling above the mean, above average, and the other half below average. And we're going to put this into perspective as we go through today. So if it sounds a little confusing, just hang tight for a second. So I was saying that you can have what's called non-normal curves. So you might be saying, well, what if it doesn't look like that? Well, in those cases, we got to make special arrangements, right? But what makes a curve not normal is maybe if you have a lot of outliers, and that's a term that probably everybody has heard. When someone scores, it's not a little bit high. It's not like everybody got a 50 and someone got a 55. It would be like someone got a 50 and then someone else got a 200, right? Exceptionally high or low scores will make a curve not normal. If you're working with very unique groups of people, so perhaps you're using a body image instrument on a group of female competitive bodybuilders that use anabolic steroids, right? So that's a very, very, very limited group. But the theory is if I kept throwing more people in there, it would become normal. Or, and this is the most common thing, and the reason for this lecture, is using poor instruments, right? Somebody rushed through the creation of making their scale, making their instrument or their tool, and didn't do it appropriately. And so now it's all out of whack. It's not working. And if it's not working, if it doesn't have that normal curve, right, you shouldn't use it. And you might say, well, how am I going to know that? Well, I'm glad you asked. There are resources to see. One, they should disclose that in any kind of testing literature that they have for you, like the pamphlets and the instruction manuals, and here's how we created it. But there's also a really great database that I'm going to show you where you can read reviews and it will tell you, hey, this thing, it's not normal, right? This is not based on a normal curve and things like that. So the takeaway, again, just to reemphasize where we're at with this. Normal curves, symmetrical. The mean is at the middle, right? The 50% line. This is the 50th. You've heard of percentiles, right? This is the 50th percentile, right? So this is where the mean is. So if you scored average, you're in the 50th percentile. If you scored higher than the mean, you're over here. If you scored lower, you're over here. Skew. So this is something, and again, a lot of this class, when there's technical language, it's just vocabulary, right? It's good information to know for when you see things, but it's definitely necessary information for your NCE. So skewness is, you've heard of a skew, right? The data was skewed, right? My information was skewed, right? It's pulled. And so what happens is, with our normal distribution, if this was, let's say that this was like height, right? Most people, I know this information just because I looked it up earlier for this presentation. I don't carry this knowledge around with me. The average height for a man in North America is 5'9". So 5'9" would be right here. And then we have some people who are a little bit taller, some people a little bit shorter. We have few people who are much taller and fewer people who are much shorter. And then we have a very little people who are very, very tall or very, very short. But now imagine Shaq walked in. Well, that's going to skew, right? Because he's off the chart. He's way over here. He won't even let me draw. He's way over here, right? And that he's pulling it. So that's going to make the average look like everybody's, 7 feet tall. So let's give a visual to it, right? Here's our normal distribution. Nice, symmetrical, no skew. Here's what it would look like if we lined up heights and Shaq walked in, right? Because he's way over here to the right of the screen. You can't see him. And he's pulling it all the way over here. This is called a positive skew. Now let's say we got an infant and we threw that tiny little baby into the data. That baby's way over here, pulling it over here. Negative skew, right? So it rearranges the data. So when we have outliers, it really disrupts our skew, right? Now outliers exist, and you've heard the term maybe savant, right? So in intelligence testing, somebody might score inexplicably high on some domain, right? They're way, way, way out on the higher end here. And that's what happens. People who pull the skew we would expect them to be their score to be exceptional. Here's another example. Income. Here's the income for San Antonio, right? We have some people who lower SES. This would be our middle SES, our moderate SES, and then our very wealthy. If Jeff Bezos came in, Jeff Bezos, the richest man in the world, if he came in, geez, it'd probably look like this. I can't draw that far. I'm using a trackpad. He would pull us all the way over here, right? It would look like we're all incredibly wealthy, right? And that's not the case, is it? Right? We're not as wealthy as Jeff Bezos. If we are looking up NCE scores, here's what we would expect the average to look like, right? We'd have most people score whatever the average is. Some people got it perfect, and some people maybe they went in and they were just having a bad day, right, and did very poorly. If one of those people was from UTSA and we lined up our UTSA scores, it's going to look like this, right? Because one of our students went in while they had like the flu, or they went in and they were just out of sorts, right? And they did very poorly. It's going to pull all the data to the negative side. And you might be trying to figure out a system to remembering which one's positive and which one's negative. Real easy nursery rhyme here. The tail tells the tail. Whichever way that tail is going, that's the type of skew, right? Here is the tail. It's going in the positive direction. Here's the tail here. It goes in a negative direction. So the tail tells the tail. I wish I would have known that in grad school. So, I know it probably seems like we're bouncing around. I promise you it all ties together. So these instruments, these scores, they're made up. Scores come from different scales, and we have different types of scales. And again, vocabulary lesson, right? We have different scales. These are what different assessments are comprised of. This is what they're made of: nominal, continuous, ordinal, interval, and ratio. A nominal scale, nominal name, it's things that put people into categories or label, right? So ethnicity, right? Religion, male, female, your grade, school counseling or community counseling, clinical mental health counseling. It's you're in a group, and it helps us classify groups, right? So nominal name. Continuous scales, which are the ones that you see often, this is where there could be really any answer. So this would be age. It's continuous because someone could answer 0, right? Because maybe, I don't know why you would, but maybe you're testing a less than 1-year-old, all the way up to 112, right? Income, right, ranging from this much money to this much money a year. Your height, between 4 feet to 8 feet. Weight, speed, scores on a test, right? They're all continuous, very specific to the individual. Ordinal scales, ordinal. This is where you're ranking something. So career counseling, it might be, what are your, if you're a school counselor and you're working with a teen and you're saying, like, what would be your number one job choice? What would be your number one college to graduate? What do you want to do first when you graduate? In addictions counseling, very common, right? What is your drug of choice, right? And they say Xanax. Okay, and if Xanax isn't there, what's your next go-to? Pot. And if pot's not there, what's your next lineup? I'll drink, right? Because it's easier to find than the other two. And so we're ranking something with body image, right? What is your least appreciated part of your body? For body confidence, what is your favorite part about your body? What are your top 3 skills, right? We're ranking. You'll definitely use this in practice, when you ask clients questions. Couples counseling, what is the priority in your relationship? Or with family counseling, what are the top 3 values of the household? The other two you won't see very much. The top 3 you see quite a bit. An interval is where the difference between 2 scores is the same. So let's say that I came up with a study guide for the NCE, and I said, my study guide is guaranteed to raise your NCE score by 10 points. And so the person who got, and I'm just making up numbers, the person who made a 100 and wanted to, for whatever reason, take it again and do better, they take my study guide and they get 10 points more, right? It helped them. They got 110 the second time. The person who got a 70 and says, I got to work on these scores, they take my study guide, they get the same 10 points. It's a 70 to an 80, right? There's not a magnitude difference. The interval, the 10 points, is the same regardless of where you started. And ratio, I always thought this one was kind of an odd thing to explain. Ratio means they have, and I'm doing air quotes, a meaningful 0, right? So that means that 0 means something as opposed to the absence of something. So if I said, if you took a test, right? I have my midterm and you took it and you got everything wrong, that's a meaningful 0, right? It means you got 0 points out of 100, right? As opposed to maybe just not taking the test at all, which would, like, you get a 0 because you didn't take the test, but it doesn't mean anything in terms of your knowledge of assessment, right? So there's a meaningful 0. 0 means something as opposed to being a place marker. I have never seen that in real life yet, though. Okay, so I made my clinginess scale. I've got some nominal scales in there, like, are you in a relationship? I got some continuous scales in there. How long has your relationship been? How independent are you? I've got some ordinal scales. List the top 3 priorities in your life, choosing from work, school, family, relationship, church, exercise, and money, right? List the top 3, right? So I've got my scales. I make my clinginess survey. And so I give it. And now comes the time to get the scores back, right? I give it to 100 people. I get all these different scores, some high, some low, some most just kind of in the middle. But what does the score mean, right? Like if someone got a 50 on it, how clingy is a 50? Is 50 on the high end or on the low end? Is it in the middle? Is it somewhere in between the middle and the low, or the middle and the high? We don't know. Just like getting a 100 on a math test or getting a 100 on our midterm doesn't mean the same as getting a 100 on your NCE, or someone getting a 100 on the STAR test, or getting a 100 on the LSAT, right? They mean different things. So scores mean different things based on that exam, on that test. And so that makes it difficult to have a universal language. And that's where we're moving to now, right? We want to have what are called standard scores. Good thing to memorize. Standard scores, right? Because it takes apples, oranges, and bananas, and it makes them all watermelon. So we're going to cover, there's lots of different types of standard scores. We're just going to cover 3. These are the 3 most common, and these are the 3 that you need to know, right? So Z scores, T scores, and IQ scores. And the reason we have standard scores is because we need a system, a common language about test scores. So that way I take the 50 on my clinginess scale should kind of mean the same thing as a 25 on the interpersonal dependence scale, which should mean the same thing as 120 on the interpersonal independence scale or something, right? So we want to be able to line these things up. So when I say standard score, this is what makes it standard. It has a standardized mean. So anytime you hear the term Z-score, you automatically know what the average is. Nobody has to tell you, right? The person got a Z-score of 1. Well, you know how far away from the mean that is, right? And a standardized standard deviation, right? Now, some of you are going to be very familiar already with this concept of standard deviation. And if you are, I encourage you to, let me know if there's a better way to explain it, because this is one of those things that once you get it, it makes complete sense, but it can be kind of weird to explain. So just take your time with this video. I'm going to explain it a couple different times. I'm going to sound very redundant. And if it sounds redundant to you, that's good. That means you're understanding it, right? So there's no system. Well, there's a system, but that's beyond the scope of what we need to go over for the course. But this is a memory game, okay? This is just memory. So as I was saying, standard scores come with a fixed mean, a fixed average, right? They're telling you anytime you use this kind of score, anytime you use a Z-score, this is the average. Anytime you use a T-score, this is the average. They're telling it to you. You don't have to figure it out. What I want you to think about it as, it's an anchor point. Because when you're working with your client, we're always wondering, how did they do compared to the average? Standard deviation, think of it as a distance. Standard deviation tells me how far away your score is from the mean. So if you got a 50 on a test, the 50 is just a floating number in space. It doesn't tell me anything. If you told me the average was 40, okay, now I got something. I know that your score of 50 is above average, right? The average was 40, your score was 50. But how far away from 40 is 50? So in other words, those 10 points, we literally know 50 is 10 numbers away from 40. But these 10 points, how meaningful are they? Is it just kind of like you and your over-competitive friend take the same test and you got a 90 and they got a 91, right? Does that mean that they're leaps and bounds more knowledgeable than you are, or that they did fantastically better than you? No, it's 1 point. The competitiveness between the two of you might, stir it up, but did 1 point really catapult this person so much further away from you? And the answer is no. What if you got a 70 and they got a 90? Whoa. Well, that's like 2 letter grades, right? You have a C and then they have an A. On the MCAT, the medical entrance exam, right? The difference between a 45 and a 46 is monumental, right? That 1 point difference is a world of difference in determining what medical school you can get into. So the standard deviation tells us how important or how impactful those points are. It tells us how far away from the mean your score is. So let me recap a little bit here. We have our midterm, you get your grade back. And I know there's got to be a handful of you that do this, right? And I will admit, I used to. So you got your grade. I got an 85. What was the mean, though? Again, 85. I know I got a B. But how did I do compared? Think of those classes that I never took one of these classes, but where they say, oh my God, the average was like a 40, right? The high score was a 50, right? When you're just given your score, you don't have anything to compare it to. But then you get the mean, you get the average, right? So here I am with my 85. The mean, and those of you not familiar, I'm not saying this sarcastically, the M with a line over it means mean or average, is an 80. Okay, I know I did better than average. And maybe I really want to pat myself on the back. So how important were those 5 points? Right? Because if the majority of people scored between, 80 and 90, the 85 kind of loses its luster. If most people scored between an 80 and an 82, I'm quite a bit higher than the average, aren't I? Right? With most people still scoring lower. So here we are. We're going to try and tie it together. Now don't shut down. This is not as intimidating as maybe it looks. This was the cleanest image I could find. And when I say don't shut down, this is coming from a person who typically shuts down when I see too many numbers. And so don't be afraid of this, right? So let's start with a couple things that we've already covered. This is a normal distribution. Symmetrical. How do you know it's normal? Because I'm telling you. This, right? So look at this. Mean, right in the middle. And then you see these little numbers at the bottom. +1 standard deviation, +2 standard deviations, +3, and then -1, 2, 3, right? So this is how a normal distribution is laid out. Now stay with me. Remember, this is our 50th percentile. That's just the way it works, right? That's the assumption of the normal curve. Now, let's take it a step further. We assume then And we would see this, right? If you kept feeding people into your survey, this is what would happen. 68% of people, excuse me, 68% of people are going to score between one standard deviation below and one standard deviation above, right? So let's say the mean was an 80. Doesn't matter what type of test. The mean was an 80. And standard deviation, one standard deviation is, we'll say, 5 points. I wish they had text boxes for this. So, one standard deviation, right? So, let's just say I was really sadistic, and you say, I want to know my score, and I'm saying, okay, I'm going to give it to you this way. The average was 80, and you scored one standard deviation above the mean. What number do you think would go here? What I'm asking you to do is add one standard deviation to the mean. What is one standard deviation in this case? 5. What's the mean? 80. 85. Let's say that a younger Chris Leith took the same exam. You all are going to do better than me, right? I scored one standard deviation below the mean. So you got to take one standard deviation away. What's that give you? 75. So back up to the 68. 100 people took this test. 68 of them got a score between 75 and 85. So let me ask you, and I want you to think about it. Like, pause this video and answer this question for me. If I said you scored 2 standard deviations above the mean, what would your score be? Really, really think about it. That's right. 90. And what would 2 standard deviations below the mean be? 70. That's right. So now we're here. 95% of people, so 95 out of that 100, got a score between 70 and 90. So let's just round it out. You did really well. You did 3 standard deviations above the mean. And you can probably guess where this is going now. 5 and 65. Right? So 99 out of 100 people scored between a 65 and a 95. Right? So there might be someone who did lower, and there might be someone who did higher, but they would be only a handful. This is another assumption of the normal curve. No matter what the average is or what the standard deviation is, these numbers here, this breakdown, this chart will always be, no matter what these numbers are, right? If it's normal, this is how it looks. I hope that was helpful. So, we're rounding out the number business. If you're feeling good, then you're almost there. Just hang tight just a little bit longer. So, percentile rank, right? So there's a common misconception, especially with I hate saying the term like lay people, but people who aren't familiar with stats, right? Or assessment, is that your percentile rank, vocabulary lesson, percentile rank is how you performed compared to other people taking the same test. It is the number of people that you scored with or higher than. So if you scored in the 97th percentile, you scored with or higher than 97% of people. If you're in the 14th percentile, you scored higher than 14% of other test takers. That also means that 86% scored higher than you. So a couple pieces of information. And there's not a good system, right? Memory. That's what I did. Some things just are what they are, and it's easier to just kind of, let's look at this, let's memorize it, rather than, kind of come up with some busted up system. So the percentile, or the standard deviations, are right here, right? Look what we had, 1, 2, 3. It doesn't matter what the scores are. Remember, the standard deviation is a unit of distance. I scored 1 standard deviation above or 2 standard deviations below. And down here we have the percentile rank. So here they're saying that the mean was a 0, and you might be saying, can you get negative numbers? And the answer is yes. Just go with this for a second. If you got the average score, you're in the 50th percentile. 50% of people scored higher, 50% scored lower. If you scored at 1 standard deviation above the mean, you're in the 84th percentile. 2, you'd be in the 98th, and 3, you'd be in the 99.9th. -1, you'd be in the 16th percentile. 2 below, you'd be in the 2nd, right? This is especially important for our school counseling friends and youth counseling, and we get to it a little bit later, but since I have it up, intelligence testing. Someone who scores here, or if you look in the DSM, someone who scores here is eligible for a diagnosis of intellectual disability, what we used to call mental retardation. And if you look in your DSM, it'll tell you that to be eligible for that diagnosis, one must take a standardized IQ test and score 2 standard deviations or lower below the mean. And I remember when I was in grad school and my professor was telling me this, and I remember my immediate reaction, I don't know why, was like, how arbitrary, right? But when you look at it, that would mean, like, if we gave this to a child, right, to a 10-year-old, it means that 98 out of 100 of his peers scored higher than he did. So this is someone who is struggling, right? So if someone is really struggling with math and we need to figure out, do they need a 504 or an education plan, and we see that they're scoring here, this is very problematic, right? Conversely, over here, this is where we might start seeing exceptionalism or savantism, right? The islands of intelligence. So let's go back to my earlier explanation with the testing. Here was 80, 85, 90. No, that looks like a 4. Oh no, 95, 75, 70, and 65. So you took the midterm and you got an 80 on it. Well, you're at the 50th percentile. If you scored 1 standard deviation above the mean, you're in the 84th, 98th if you got a 90, and so on. And this model, these percentile ranks and everything, they would exist and they would be this way regardless of what any of these scores are, right? You could swap out and put in any of the numbers as long as they follow the system, right? You have a mean and you have a standard deviation, then you can figure out the rest of it. So, we're almost there. When we get a score, like before we change anything, what I was talking about earlier, that score that's just kind of floating there, that 80, right? Or the 50 on the clinginess scale, that's a raw score. It's an unmanipulated, haven't done anything to it, haven't transformed it, is what we call it. Haven't done anything to it. That's a raw score. And that's where I was saying, a 50 on one test is not the same as a 50 on another. So that's where the standard scores come in. So the example here is if Simon got a 20 on the conformity to masculine norm scale, is that the same thing? Did he score lower on that than Michelle did on the body image distress scale, right? It's apples and oranges. So a z-score, right, and this is a type, so you're writing down on your PowerPoint z-score, is a standard score. They have a mean of 0. So anytime you hear someone say z-score, you know the average is 0. And it has a standard deviation of 1. And so, yeah, that's when I was saying, what about these negative scores? That's where they come from, right? So let's look at it. Here's a z-score distribution. Remember, a z-score has a mean of 0 and a standard deviation, oh man, that's bad, of 1. So here it is. You got a 0. You're at the 50th percent. If you scored 1 standard deviation above, you got a 1. If you scored 2 standard deviations below, you got a -2. If you scored half a standard deviation above the mean, what is your score? Take a second. Half a standard deviation would be what? That's right, 0.5. So let's try some basic test questions, right? What is Nina's score if she scored 3 standard deviations above the mean? How did Mark do if he scored 2 standard deviations below average? Write it down. Nina scored a 3. Remember, the average is 0, and she scored 3 standard deviations above that. Mark scored a -2. He scored 2 standard deviations below, right? Here's the average. Nina did 3 scores above. 1, 2, 3. Mark did 2 below. 1, 2. So z-scores help because they standardize, but they're not perfect, and it can be difficult. Imagine telling a parent that your kid got like a -2 on something, or a negative, 1 3/4, right? It's awkward. So we have t-scores. Now t-scores, here we go, right here. This is what you're memorizing. T-scores, they're much more precise, and it gets us out of the business of doing like negative scores. T-score has a mean of 50 and a standard deviation of 10. So here we go. Look, it's all lined up too. 50. Here's 1 standard deviation. Here's 2 standard deviations. Here's 3 standard deviations. And what do you see above it? The z-scores. Look, a z-score of 0 is the same as a t-score of 50. A z-score of 1 is the same as a 60. 2 and 70. Because it's a distance. It's telling you, regardless of the numbers, how many standard deviations away, right? It's a universal language, standard deviation, instead of saying, a 50 on the clinginess scale. I can say they scored average, or they scored 1 standard deviation above, and that immediately gives us information. See how the percentile ranks work the same way, right? They still line up. As if you got a 0 on the midterm and I scored it on z-scores, you got average. If I said, nah, I'm going to do t-scores, or if I said for extra credit, why don't you turn it into t-score? And you'd say it's a 50, because they're the same. They're both an average, or the average. And then if I said for a few more points, what's your percentile rank? 50, right? It all lines up. It's apples to apples now. So let's try a couple test questions here. If I have a z-score of 0, what is my t-score? If I have a t-score of 65, what would be my z-score? Take a second, pause the video. All right. A z-score of 0 would be a t-score of 50, and a t-score of 65 would be a z-score of 1.5. So let's go back and check this. No. Fine. So 0 and 50, because they're both at the mean. Now that 1.5 might be throwing some of you guys off. There it goes. Remember, here's our mean. So the 1.5, right? So I said a t-score of 65. That's right here. Now, yes, you could just line them up and visually look, but let's explain it, right? So a 65 would be 1 standard deviation, and then half of a standard deviation, right? 1.5 standard deviations. What's 1.5 standard deviations on a z-score? It would put us in the same location, 1.5. All right, home stretch, everyone. We're doing it. Big things. We have IQ scores, and you'll be surprised to hear that they measure IQ, right? And so what you're looking for or looking to memorize is this. They have an average of 100 and a standard deviation of 15. Some of you are probably thinking, what? A 100 is the average? That's right. So all your friends who took the BuzzFeed intelligence test or whatever, and they say, I got a 100 on it. They scored completely and utterly average. So let's kind of work on this together then. Oh my goodness, I just want to use the eraser. There we go. Okay, so I want you to pause here, and I want you to fill in the IQ scores, okay? And where do you think they would go? Now remember, IQ has a mean of 100 and a standard deviation of 15. So put this in line with the z-scores and t-scores. I'll wait a second. Or actually, you could just pause and do it. So the 100 would go here, because remember this is where the mean is. What would 1 standard deviation above be? 115. What would 2 be? 130. And 3 would be 145, right? And so we have a whole section on intelligence testing, but it's here that's where we start seeing like the extreme giftedness, like the photogenic memory or the very, very quick processing speeds, the giftedness with math and stuff like that. And so oh my goodness, this is more information than you guys care. I'm not good at subtraction. 85. And then 2 would be 70. And God willing, 55. So if you plotted that, perfect, you got it. So what you need to do is memorize these, right? Memorizing the mean and standard deviation for each of these things, right? That a z-score has a mean of 0, a t-score 50, IQ 100. The standard deviation for a z-score is 1, standard deviation for t-score is 10, and the standard deviation for IQ is 15. And if you memorize that, you can manipulate the numbers however you want. There's no math involved. This is just changing stuff. right? Going from inches to feet to miles, right? Let me go back. Yeah, let's work on this one. Okay. Let's say that we were looking at height. Remember, I had said that I randomly had that knowledge, had been looking it up. So for men, the average height is, let's say, is 5'9". So in inches, that would be 69 inches, right? If we were to convert that to meters, 1.75, and then to centimeters, 175. They all mean the same thing, right? They're just telling you this is where it is, this is where it lines up. And a standard deviation above, right? If it's a standard deviation of 2 inches, then you convert it accordingly, right? We're just lining things up to have a common language for scores. So this was a lot to review. Please, please, please let me know if you have questions or concerns. Those of you who are very proficient at it, if there is a way for me to explain things, even if it's just a different way, let me know, because this can kind of be a little bit confusing. But once it's down, it's down. Do not give up. Don't shut down. I see a lot of people kind of shrink away when this stuff comes up. If you can get a hold of what we covered in this video, you've got it locked down. You are set 100%. So we just need to make it through this piece, memorize those scores, do the quizzes. There's some extra worksheets and stuff up to just test your knowledge, right? And if you feel like it's confusing or I went too fast or wasn't clear, please let me know, right? Let me know. That's your responsibility for the class to give me that feedback so I can help be a better instructor. So if I can help, please let me know. That's going to do it for today. I hope everyone is well. I'm going to leave it here, and we will pick up with reliability in the next week. Take care, everybody. Well, hang on, everybody. I'm trying to close out here. Oh, all right, bye.